PT2.
PT2 is coming. Will come.
Yes.
And
October
when?
12th starting.
October 12th. Okay, and what's the syllabus, Zaraa?
Chapter 5 and chapter 6.
Chapter 5. These two, work energy and rotation.
Not rotation, the other one, ma'am. 1 second.
Gravitation.
No. 1 second, ma'am. I think she forwarded the paper to me. I'll just open it. Yes, ma'am. Chapter 5, work energy, and chapter 6, system of particles.
Yes, that's rotational motion. No. System of particles and rotational motion.
We did
That
not
I
start
see.
that chapter. She sent me the portion.
Okay, so right now you are on which chapter in the school?
Work energy power.
Work energy and power. So let us complete. We were just on the last topic, collision. So let us complete collision. And then we'll start with rotational because that system of particles chapter is a little lengthy. So it will take time, and it's the best thing that if we complete the syllabus on time and we get some time for us to have a practice session so that this can help you with the numericals part. As you said, you're fine with the theory part. There's a difficulty with the numericals. So let us let us complete this much. Let's see how much we are able to do. Otherwise, extra classes and all can be arranged. Okay.
Okay, ma'am.
Can you just see what all have you written last?
I did these notes for collision and then I had to write what was there next.
Collision, types of collision have you written?
Yes, till here. I had to write this elastic and elastic. You had explained elastic and elastic, but I did not write it.
Okay, this you have to write right now.
Yes.
Okay, you write it, then I'll start with the coefficient of restitution. Okay.
Okay. Done, ma'am.
Okay. The basic difference, collision is basically what was collision. Let me now just recall. Two bodies are there, they're moving with certain velocities, they collide among each other, and then they move apart with different velocities. Now, when they are colliding, the net force between them is zero. Okay, resultant force between them is zero. Because that is what is known as isolated system. Now see, what is elastic, what is inelastic conservation? Collision, not conservation, because one is conservative. Elastic collision and inelastic collision, the major difference is that in this elastic one, elastic. Momentum, kinetic energy, both are conserved. In elastic, this one, in elastic, only the momentum is conserved, kinetic energy is not conserved, and that will help us derive all sorts of things. Now, what is coefficient of restitution? Let me tell you this. Coefficient of restitution is basically the ratio. This also you couldn't write, no, in the last class. Coefficient of restitution was also left. See,
Yes.
to identify whether the elastic collision has occurred, inelastic collision has occurred, or whatever kind of collisions have occurred. E is a value that is like a constant by reading which you will get an idea about the type of collision. So coefficient of restitution is it's just a constant and nothing else. Like E is equal to 1 for elastic collision, less than 1 for inelastic. There is a case if two bodies are moving and after colliding, they stick to each other. Instead of getting separated, both the bodies get stuck to each other and move with the same velocity because now they are not separated. That is known as perfectly inelastic collision. That we'll see once we'll jump into an elastic segment. So in that case, the value of E is 0, like this. So while reading just whether E is given as 1, less than 1 or 0, you will get various values already. Now, if we have, let's say, M1 is there, M2 is there, they both have their own initial velocities, they both have collided, and these are the final velocities. So we have relative velocity of approach. Relative velocity of approach means when the bodies are about to collide, they are approaching each other. So the relative velocity is of before collision. So relative velocities of approach means both the bodies are approaching each other. Now they can approach in this manner also. They can approach each other in this manner also, opposite also, and same side also. Now here we take the initial velocity of the object 1 as greater. Because if this object's velocity is not greater, it will never be able to overcome it. If this is always 3 meter per second, this is 5 meter per second, it will always move forward with 5 meter per second. This will move slowly with 3 meter per second. So this has to be greater so that collision can actually occur. That's why instead of writing u2 minus u1, we write u1 minus u2. Now this is the collision here. This is the actual event which we call as collision. Now velocities have separated. Now, when the bodies are getting separated, they'll be moving with some velocities. That is known as relative velocity of separation. Okay, this is known as relative velocity of separation. That is final velocity minus initial velocity, the way we usually take the difference between any two velocities. Because here is no condition, you can have anything. And all of these depend on the magnitude actually. What is the magnitude of the velocity? What is the magnitude of the mass given? I'll share a few cases with you where you will see how this is done. Now, coefficient of restitution was basically the ratio of velocity of separation, means the final ones first by the approach. And we'll prove also, there's a proof in your exam also that comes that elastic collision is equal to, means E's value is 1 for elastic collision. That we'll derive right now. But till here, is it here? Now is it revised, whatever we did in the last class?
Yes, ma'am.
Okay. Write down this part, then let's do the derivation of it.
Ma'am, I already wrote these things. I only had those comparisons.
Only
left.
this was left.
Yes, because I couldn't write it on time that day, so I wrote everything else.
Okay, okay. This part is written, coefficient of restitution.
Yes, this is written.
All right, okay. Now I'll start with collision and bending. So just pay attention. This is important. This comes in the exam often.
Okay.
Basically, two things are getting conserved because it is elastic collision. One is your momentum, one is your kinetic energy. Just keep this in mind. For numericals, these 2 points are really important. See, rest of the points are important for your theoretical questions. Like what is the difference between elastic and inelastic collisions, like these. Okay, all of these kinds of questions are important for those differences part. But if the actual literal question comes from the collision, important part is you should know momentum and kinetic energies are conserved and how to write those equations. Because whatever will be the final answer, you will be able to write it. That's okay. You'll be able to write it. You'll be able to remember the formula also. And some of the questions might be solved. But see, from the scratch, the way you say, sometimes it troubles you with the numericals. These things help. Make the basic equations first. They'll always be helpful. Let's say this is M1, this is U1. M2 moving with a velocity U2, and this whole case is before there. During they have collided, then M1, M2, and moving with their individual velocities that are V1 and V2 afterwards. Now, momentum, if momentum is conserved, conservation of momentum means whatever is the initial momentum is equal to the final momentum. So I can say M1 U1 plus M2 U2. Now, why? Why am I writing this? See, momentum is equal to mass into velocity. For the first object, whatever it is, 1 kg. Okay, I have not written any value right now. For the first object with, let's say, M1, moving with some velocity V1, U1, anything, you put it here and you calculate the momentum. So M1 U1 plus M2 U2 is equal to, now the final case. Final case means once they have separated. This is equal to M1 V1 plus M2 V2. Let's just shift the terms. One terms together and two terms together so that it will be easier to take the common part. So I can say M1 U1 minus M1 V1 is equal to M2 V2 minus M2 U2. So from here, if I take M1 common, that is U1 minus V1. If I take M2 common, that is V2 minus U. This is one equation. Until here, momentum conservation.
Yes, ma'am.
Okay. Now here we just have one more benefit because it is elastic. Kinetic energy will also be conserved. Now kinetic energy's formula is simply half mv square. So here we are going to apply this. See, half will be cancelled from other side. Half m1 u1 square plus half m2 u2 square. Finally, half m1 v1 square plus half m2 v2 square. This will be m1 u1 square plus m2 u2 square is equal to m1 v1 square plus m2 v2 square. Now see here also, let me change the term. One terms I'll bring together and all the two terms I'll bring together. So look, m1 u1 square minus m1 v1 square is equal to m2 v2 square minus m2 u2 square. Now I'll take m1 common from here and u1 square minus v1 square is left. From here, m2 will be taken common, v2 square minus u2 square will be left. Now, Zaraa, can you recall any identity while seeing this term or this term?
From laws of motion?
From your maths.
No.
A square minus b square.
Oh, yes.
Yes?
I thought you wanted from velocity.
No. A square minus b square is equal to?
A square minus 2ab plus b square.
That is a minus b whole square. A square minus b square is equal to a plus b into a minus b. Okay?
Oh, yes. Sorry, I
This
got
one.
confused.
Yeah, that is the complete whole square one. So if we put in the values here, see, m1, u1 minus v1, u1 plus v1. This is m2, v2 minus u2, v2 plus
U2.
u2. Okay, this is the second equation.
Okay.
Now, this equation was already there from momentum. This equation is there from kinetic energy. Am I clear till here, Zaraa, properly?
Yes, ma'am, you are.
Okay. Now what I'll do, I'll just take the ratios of both of these. So when I'll take the ratios of both of these, m1 minus v1 is there.
Is the whole derivation important or just the formula?
Derivation, that's why I'm discussing. This derivation is there, it comes. To prove why the coefficient of restitution for elastic collision in 1D is 1. And out of all of them, whatever we have discussed, whatever we are going to discuss, the most important will stay this one. So that's why this, but steps are actually easy. If you practice it 2 times, it's sufficient. U1 minus V1. This is M2, V2 minus U2. From where? First equation. Divided by. This part is M1, U1 minus V1, U1 plus V1.
V1.
Yeah. Similarly, this M2, V2 minus U2, V2 plus U2. See here, this bracket gets cancelled. This bracket gets cancelled. Masses get cancelled. Here also the masses get cancelled. What exactly are we left with? Look, U1 plus V1 is equal to U2 plus V2.
V2 plus, yes, ma'am.
V2 plus U2, U2 plus V2, yes. Now, if I shift the terms together, U1 minus U2 is equal to V2 minus V1. This is what we started with, that this is the relative velocity of approach and this is the relative velocity of separation, one thing. Second, if I bring this term here, U1 minus U2 below, means V2 minus V1 divided by U1 minus U2. This will be equal to E. That is the coefficient of restitution. Now see, how can you say both are equal? Coefficient of restitution is this. These will be cancelled. What is E equal to? 1. Clear?
Yes.
Okay, now there are two formula which will always help you get the velocity in just one line. Difficult part is to remember the formula by itself. So that you'll have to do, Zara, by yourself. Formula I've already written, and you don't have to derive anything from this formula, for this formula also and from this formula also. But we'll practice numericals and numericals will come. So you just have to substitute the value in these two formulas. I have already derived them, and derivation is not a part of your syllabus. Okay?
Okay.
So write it till here properly, understand every point. If there's difficulty, let me know. Just text me or done. Once completed, just type done in the chat box. Okay, write it, then we'll practice some questions.
Okay. Done, ma'am. Can you scroll it down? Ma'am, just one line up because I cannot see the blue lines written on the side. Yes. Done, ma'am. The blue lines. You can scroll it. Done, ma'am. Done, ma'am. Done, ma'am. Done, ma'am. Done.
Okay. See, this question says predict the outcome of collision, assuming it to be elastic. Means after collision, what will be the exchange velocities of each? See, we know m1 is given as 2 kg, while its initial velocity will be u, not v. Initial velocity is u. u1 is 5 meter per second. m2 is 4 kg and u2 is equal to 2 meter per second. Now see here 2 is taken, 4 is taken, 5 and 2 these are taken. Now the formula is v1 u1 m1 minus m2 plus 2 m2 u2 by m1 plus m2. So here basically v1 has to be calculated and v2 has to be calculated. The problem is that both the velocities are acting in opposite direction. So Zara, now whenever velocities or any kind of vectors are acting in different directions or opposite directions, you will have to choose a sign convention from your end. Let's say this is positive, so this will be negative. That you'll have to put. So this will be u1 m1 minus m2 plus 2 m2 u2 divided by m1 plus m2. This one u1 m1 minus m2 plus 2 m2 u2 by m1 plus m2. So v1 will be u1. See, u1 is 5. This is minus 2. So 5 into, see, this will be 2 minus 4. 2 minus 4 plus 2. m2 is 4. u2 is minus 2. As it is, just put in the values. Here, this is 5. Divided by masses are 2 plus. So this is minus 2. Minus 2 into 5 is minus 10. 4 minus 16. Minus 16 by 6. So see, this is equal to minus 26 by 6, which is minus 13 by 3 meter per second. Now, what is this minus sign telling? If this velocity is coming negative, what is this minus sign telling? Minus sign is basically telling the direction. Like, see, I have chosen right as positive and left as negative. The right is positive and left is negative. In that case, if my answer is coming negative, that means this is telling the direction that it is towards the left hand side. Means the body will move towards the left hand side with a velocity of 13 by 3 meter per second. Now got it?
Yes.
Okay.
So I
Sure.
can give sign convention according to what I want. I don't have to
Yes.
follow anything.
Nothing. But you have to specify what have you chosen. Like if I don't mention negative is left for me, my answer can be anything. It can be wrong also. See, even if you choose the opposite sign convention, let's say you have chosen left as positive, your answer will come positive automatically.
So it'll
Answer
become
cannot be
plus
different.
13 by 3?
Yes, that will become plus 13 by 3, which will again be 13 by 3 in magnitude and direction will be left. Answers will never be different. Got it?
Just sign will be different.
Sign will be different. But sign
Okay.
convention will have to be specified from your end. If you do not specify, you will lose every mark.
Okay.
Because what negative? It's like what negative? So you have to specify negative is left. Just make a sign convention small box like this in the upper corner. Okay. Regarding second velocity, see wherever you see 1, you put 2. And wherever you see 2, put 1. So u2 m2 minus m1 plus 2 m1 u1
1,
divided by m1 plus m.
2.
So u2 was minus 2. Minus 2 into 4 minus 2 plus 2 into m1 is 2, velocity is 5, 2 into 5. 2 into 5 divided by 2 plus 6. So this will be, see, this is 2 minus 4. This is plus 20 by, this is 4.
8, 6.
Because I by mistake wrote. It will be 6. So this is 16 by 6. That is
13
8
by 3.
by 3. 8 by 3 meter per second. Now I'm getting a positive.
Right side.
Sign, right side, exactly. Now, how do you have to answer this in a better systematic manner? Is this clear? What are the magnitudes of V1 and V2?
Yes.
Now, see, if I am getting this value or this value, I'll specify my answer like this. Final velocity of 2 kg body is 13 by 3 meter per second towards the left, like this.
Okay.
Or final velocity of 4 kg body is 8 by 3 meter per second towards the right. You have to specify which velocity, because if it's not mentioned in the question. Got it?
Yes, ma'am.
Write down this numerical, and then we'll see some special cases based on this.
Can I go and get my charger?
Yes, Zaraa, please.
Done, ma'am. Done, ma'am. Done, ma'am. Ma'am, done.
Okay, see, there are certain special cases in the sense that will help save your time in the calculations when the exams have these kinds of questions. First is if the bodies are identical, like M1 and M2, both are same. 3 kgs, so both 3 are 3 kgs. 4 kgs, so both are 4 kgs, like this. All the masses are same. That is what is meant by identical. Now, when we put in the values, here this won't be. M means M1 and M2 are equal to each other. So what will happen? 2 by 2m. Okay. So 2m, 2m will be cancelled from this side. So V1 is equal to U2 and V2 is equal to U1. Got it? Means the velocities will be what has happened actually here. Whatever is the final velocity of the first body is actually now equal to initial velocity of the second body. Velocities have been interchanged and exchanged also. Got it?
Yes, ma'am, got it.
Okay. So M is U1, this M is U2, this M is U2, this is M, means this was U1, now this becomes U2, this is U2, this becomes U1. Okay, so this one is the first one. Second is C, yeah. If the second body is very much greater, okay, the second body is very much bigger in size than the first body. Like M2 is a very huge body. So it won't be moving. How will the collision occur? Smaller body will come and it will collide with the bigger body. It's like a truck has been parked and a bike hits it from behind. So initial velocity of the bike would be something, but the initial velocity of the truck will be nothing, especially in comparison with this bike. Whatever would have been the speed of the bike and whatever could have been possibly the speed of the truck, they aren't comparable. Are you getting this point? Why it is taken as 0 if the body is massive? So
I'm a
what
little
you do?
confused
Yeah.
in this one. Why are we taking 0?
Body is not moving. Our big body, this is a very huge body and this is stationary. This is stationary. So how is the collision occurring? Collision is occurring by the movement of the smaller body. So what will happen? Big body is there, smaller body comes and collides like this. These collisions are also possible. Are you getting it now?
Yes.
It's like if there's a big truck. Okay, this is a big truck, and here a small bike has collided with it. The truck is at rest, truck is parked. This truck is parked, and this bike is coming with a full velocity and hits it. Now, m1 minus m2 is almost, see, the masses, it's negligible to take the mass of the first body because your second mass is huge. That's the condition, and these conditions are given. So, m1 minus m2 is almost equal to m2, and m1 plus m2 is also almost equal to m2. It's like from 1000 you're subtracting 9, or from 1000 you are adding 9. This difference. So it will almost be equal to 1000 in both the cases, whether it's 1009 or it's 901, right?
Yes.
So V1 is equal to U1, M1 minus M2 plus 2M2 U2 by M1 plus M2. This whole part becomes M1. This whole part becomes M2. This whole part becomes M2. While this part will be 0 because U2 is equal to 0. This becomes U2 becomes equal to 0 in this case. Right? Here's U2 is equal to 0 in this case. So what are we left with? V1 becomes equal to U1. Means the velocities get interchanged only. They don't get exchanged among themselves. They are just changed. Means the final velocity of the first body will be the initial velocity of the first body only. Like the previous cases, they were getting interchanged among the bodies also. Okay, so V1 is equal to U1, and similarly for V2, do one thing. When you write now after this, just write it for this also so that you have the notes completed. Now the last case. One is very huge, so same thing. It will also be exchanged. But just remember, just in V2, it will be 2U1. This is something that you have to remember. And by this, your questions will be very easy to solve. We'll practice questions at the end also. And before your exam also, we'll practice. So this way, by using this main formula, and this will help you remember this original formula. You don't have any derivation for this, just remember it as it. Remember the value of E, and that's it. I think just one common velocity from perfectly inelastic is left. Rest of the derivations are almost done. Till here, is it completed? Is it clear? Oh. So Zara, write down these 3 special cases, and
Are
then
we done with the
yeah, chapter will be done right now. Only few minutes are left. Means inelastic collision is there. That will be completed.
Okay. Done, ma'am. Done, ma'am. Done, ma'am. Ma'am, you can scroll the whole thing. I just want case 3. Done, ma'am.
Okay, sir. Now coming to inelastic collision. Okay, sometimes it can be a little confusing to hear because elastic and inelastic in space elastic. So elastic, I'm not discussing now. Elastic is done. Now inelastic collision. Okay, the inelastic collision is the one where kinetic energy is not conserved. So you don't have as such derivation or anything. Just in case if a question comes, you use this statement: m1 u1 plus m2 u2 is equal to m1 v1 plus m2. Okay, your numericals will be solved using this. Don't ever apply the kinetic energies equation to get any of the values. Only conservation of momentum. Fine. This you'll be able to do.
Okay, ma'am.
Okay, now what is perfectly inelastic collision? Perfectly inelastic collision means, see, both the bodies are there. They are moving with different speeds. They get collided among themselves. Now they stick together. Instead of getting separated to some different velocities and moving at different angles or in a straight line, they move with a combined velocity. That velocity is sometimes asked in the question to derive also for 1 mark or 2 marks. Zara, you have a test also of work energy in power. I think tomorrow.
Tomorrow, I don't think so, ma'am. They gave me dates.
So which one have you? I think it's
Yeah.
according to you only Saturday.
Yes.
Saturday. So anyway, so collision will not come. Okay, collision will not come because this has been just done today only. So it will be difficult for you to revise. But whatever we have done before from your work energy in power chapter, everything will come.
Okay.
Now see, here it's also very easy. When I talk about the initial momentum, see, momentum will be conserved. Initial momentum is equal to final momentum. Kinetic energy is not getting conserved. Momentum can be conserved. And see, why is this happening? Like, why am I able to get momentum being conserved and I'm not able to conserve the kinetic energy? The reason is that momentum is a vector quantity and kinetic energy is a scalar. Speeds are not getting conserved, so kinetic energy is not getting conserved. Velocity is getting conserved, so momentum is getting conserved. So you have to apply your little knowledge of vectors here. A little bit of vectors will be used. Initially, this is m1 u1. What is the momentum of the formula of momentum is mass into velocity. Its formula will be m2 u2. We'll add them. This gives us the initial momentum. Then finally, see, both of the bodies have the same velocity. So m1v plus m2v, like this. Instead of having different velocities, they have the same velocity. Now here, if I say m1 u1 plus m2 u2, and I take the v velocity common from them. Okay, v velocity, so that is m1 plus m2. Okay, this one will be m1 plus m2. Now from here, if I write the velocity v, this is m1 u1 plus m2 u2 divided by m1 plus m2. Clear? This is known as this velocity. This is the velocity with which both the bodies will be stuck together and they'll be moving together. So this velocity, this is known as the common final velocity. This is known as the common final velocity. So this common final velocity can be asked to you in your 2 marker questions, not more than that. So this is not very important and it's not very difficult also. Even if it comes, you will be able to manage. It's just a single common velocity. Questions won't be tricky or tough from this inelastic.
Okay.
Whatever kind of questions are there, based on these two velocities have only been asked usually in the exams. And from the elastic one, this coefficient of restitution comes. Elastic is a little lengthier because you have elastic collision in 2D also, that also we'll discuss. So that can be asked like this. If this is a question, a very easy, simple, straightforward question, and you will get the answer also very quickly. This says that find the velocity, means the velocity with which they'll be moving. Okay. P, mass is 2 kg, V1 is 5 meter per second. Second mass is 3 kg. Second velocity is 2 meter per second. Now see, this is fixed. Actually not V, these are U. These are all the initial velocities. Final velocities we have to calculate. So this is U1, this is equal to U2. Final velocity V1 will be actually equal to V2 only, which is V, the common velocity. So straight away use the formula M1 U1 plus M2 U2 divided by M1 plus M2. This is the formula for the common velocity. Now we are going to put the values individually. So 2 kg is there, 5 meter per second is present. So here when we calculate the velocity, M1 is 2 into U1 is 5 plus M2 is 3 into this is 2 divided by M1 plus M2 is 2 plus 3. So this is C. Here we have, this is, now one more thing, Zara, we have to check whether they are in the same direction or not, because both of them, if they are positive. So look, both of these are in the same direction. Now you can take them as positive. Got it? Because if any one of it was in the opposite direction, then you have to apply the sign convention. So anyways, this is 10 plus 6 divided by, this is 5. So finally the velocity is 16 by 5, that is 3.87 around meter per second. But this is the velocity with which both the bodies will be stuck together and be moving. Got it? Am I clear, Zara?
Yes, ma'am.
All right, please note it from here. Then let's move to the 2D part, how to solve 2D, two-dimensional elastic and elastic collision. And then this chapter is done, and then we'll start with the rotational motion chapter. Okay, please write it.
Okay. Done, ma'am. Done, ma'am. Done, ma'am. Done, ma'am.
Okay, see, just elastic collision in 2D. Elastic collision in 2D means two objects are moving and they collide among themselves and they move in different directions. Okay, they move in different directions means they don't move in a straight line like this. Till now we just studied head-on collision. So when they move in different directions, they will form certain angles. So angles are there. Angles means you have to solve everything, resolve everything along x and y axis. Just understand the method, Zara, because these things only help in the numericals part, and these are the points. If they are not done properly, they create a problem. So questions you'll be able to solve. I'll tell you from collision, questions aren't tough. I'll share an assignment today. Was that assignment issue resolved, Zara?
Yes, ma'am. I can now upload it. I got my laptop, so it's fine.
Okay, you're able to upload it now? Great then.
Got my
So
laptop, so it's done.
yesterday you haven't uploaded anything till yesterday.
Yesterday I did not get anything, I think so.
Okay, no, the past assignments, they are over.
You want me to upload them, ma'am? If you want, I'll upload them now.
Because I haven't checked any assignment of yours. No, it's better. I'll just tell the team to mark the assignments pending so that you can upload it properly in the portal now.
Okay.
So that I can at least check. I have not seen any assignment of yours. And one more thing that you have done, you are already done with it properly and on time. You have completed each of them. So it should be checked properly so that if you have any doubts, we can discuss them also. How did you find the assignments?
I found them very connected to the class. It wasn't very different from what we did in class. So
Okay, fine. Now, some of the questions you will find, like, not I think in this chapter, but in other chapters, sometimes the questions, some questions you will find them very difficult also. Some are just direct from NCRT also. Some tough NCRT questions. So if anything that happens, no, just attempt it from your end. Whatever you're able to do without the help of any internet or anything, just attempt it from your end. And I'll be discussing them in the class if you find any of the questions. Till now, I think if you are able to attempt all of those properly and you are able to understand, then that's good. It means you have understood more or less the whole chapter. Okay, yeah. So I was saying this is, let's say, some theta 1, this is theta 2. we have to resolve the velocity because mass is already a scalar. Mass is already a scalar quantity. So what will we do? We'll resolve the velocity. Just a second. Yeah. So velocities we'll resolve. So we'll have v1 cos theta along this edge. Why? Because the angle is adjacent to it. Then here we have v2 cos theta. And perpendicularly we have v1 sin theta, v2 sin theta. Now see Zara, is the body moving or are both the bodies moving along the y-axis in any form? No, they are just moving along the x-axis, that is one side. So when the body is moving along one side, it means y-axis has no momentum present. Momentum along y-axis is zero. The initial momentum along y-axis is zero. Here in this part, there is only momentum. This is m1 u1. This is m2 u2. This is the initial momentum along x-axis. This is also the initial momentum along x-axis. Is there any initial momentum across the y-axis, Zara? Yes or no?
No.
No, there isn't any. So what we'll do, m v1 cos theta will be the final velocity instead of using m v1. Similarly, instead of using m2 v2, we'll use m2 v2 cos theta. This is just additional for the x-axis. Wherever we had just m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now we will have m1 u1 plus m2 u2 is equal to m1 v1 cos theta plus m2 v2 cos theta. Theta 1 or theta 2 can be the same. I am just taking a general form. They can be same also. Usually they are same and it is given as 45 degrees. I've seen in most of the papers, theta is given as 45 degree if it comes because it's not very difficult. And many students think that's a very tough topic, collision, then that too elastic collision and that too in 2 dimensions. It's nothing. It's simply conservation of momentum, but instead of using v1, you take the component of velocity that is present. And see, there is no initial velocities, initial momentum component along y-axis. So initially it is 0, but finally it is m1 v1 sine theta equal to m2 m minus m2 v2 sine theta. Because both of these are in opposite directions, so you'll have to choose a sign convention. And again, Zara, that sign convention is up to you. You just have to mention which side you are taking as positive, which as negative. Up as positive, down as negative, up as negative, down as positive. Whatever is your sign convention, you just have to specify. So y-axis will be initial will be 0. This will be m1 v1 sine theta 1 minus m2 v2 sine theta 2. This is the second equation. So from here we can say m2 v2 sine theta 2 is equal to m1 v1 sine theta 1. This is one equation that is used. This is not a derivation, Zaraa. For the elastic collision in 2D, here you just have two derivations. Not even two, you just have the coefficient of restitution's derivation. Other than that, you don't have any derivation, and that too just for the elastic case, for collision. But these points are helpful in the numericals. Just in case if you're lagging and you require some equation, you can use these. So m1 v1 sine theta 1 is equal to m2 v2 sine theta 2 can be used. And this one, m1 u1 plus m2 u2 is equal to m1 v1 cos theta 1 plus m2 v2 cos theta 2 can be used. Usually using this equation, your answers will be solved. One of the component will be missing, rest everything will be provided. But sometimes two variables are there, so you require two equations. So for that, you can use this equation also. Otherwise, this is fine. If I say m1 is given, u1 is given, u2 is given, v1 is given, theta 1, theta 2 given, m2, v2, m1 all given. Only u1 is missing. With a single line, you'll be able to calculate the answer. But what if I say m1 and m2 both are missing? So you require something from this equation. That's why you study the equation and then you can apply. And since it is elastic collision, you can apply the kinetic energies conservation properly. And here you don't need to resolve the vectors. That's why I've written this separately. No need for resolution of vectors because these are kinetic energy is a scalar quantity. It involves half mass into square of the speed. So directly use it, no need to take the component because velocity is a vector. If you take the component, it means you are taking a vector part. Clear? Zara, have you
Yes.
understood? Okay. That completes with work, energy, and power. practice. If you have any trouble, I think we'll have the class on Wednesday now, so we can discuss. Okay, please write it first.
Okay. Done, ma'am. Done, ma'am. Done, ma'am.